Hi everyone, thank you for stopping by and listening to our talk. My name is Pär Degerman. I'm the CTO at Einride, and together with me I have my colleague Pia.
Hello, my name is Pia Fåk Sunnanbo. Brief presentation. I'm a software engineer. I've been a software engineer for 15 years, but now I carry the fancy title of Vice President of Engineering. So I'm a boss, but I'm a little less bossy than Paris.
Well, I guess that would make me the big boss then. Okay. Anyway, over to our speech. First, a brief introduction about Einride. We are a startup in Sweden, and we were formed just a few years ago. We are in the transport sector, and we are here to revolutionize transport in a way that we are making it electric and also autonomous. The kicker here is that we're making it in a way that's cost competitive with current legacy diesel-based solutions. So in essence, we're saving the world by reducing carbon emissions, but we are doing that in a way that's cost competitive with the current solutions. And what are we about to talk to you today? We would like to talk you how we attack the problem of this very, very big problem. We have large ambitions in the company, and we are still a very small company. So how do we do it? How can we accomplish so much with so little resources? That's really the gist of the speech that we're gonna give you today. And first, let's speak about the problem that we're trying to solve. Today, road freight transport stands for 7% of the global CO2 emissions. And as you all know, CO2 emissions is a major contributor to global warming. And this is something that we'll have to solve. And I think that you can solve it in one of two ways. Either we change our way of living and we accept that we cannot have exotic fruits on the table here in the northern parts of the globe, or we change the way that we move stuff around. At Einride, we are hellbent on the second. That is to revolutionize transport in a way that it's solving the issue of emitting so much carbon. The challenge further today is that due to the patterns that we see, our purchasing patterns and so forth, we see a yearly increase in the demand for transport. But there's an ever-growing challenge of finding truck drivers. Today, it's not a very attractive job being a truck driver, and due to the fact that cost is being pressed down so much, working conditions for truck drivers are getting worse and worse globally. There's also very little action for change in the market. Current companies, they are trying to survive day by day, and there's not really much room in that trying to change the way that you do transport. So at Einride, we come from the side. We say, hey, there's a different way here, and we can solve it for you. And of course, in all of these challenges, if you're a new entrant into this market and you think of the challenge in a different way, there's a big opportunity. The opportunity that we see is that we can lower the carbon dioxide emissions by 90%. This is based on Swedish energy mix with a large portion of renewable energy sources, but it's actually including the incumbent emissions that are stored within the batteries, which come from the production of the batteries, something that's often criticized when it comes to battery electric vehicles. This is something that we take into account when we're calculating how much CO2 that we save for our customers. Thanks to the robotic precision of the planning that we do and the way that we execute transport, we can decrease the operational costs. This is of course also connected to the decrease of cost for fuel, since we aren't using diesel fuel and electricity is in many markets a lot cheaper than diesel fuel. then that cost is of course lessened quite a bit when you go electric. The productivity increase comes from more careful planning, allowing for higher utilization of the vehicles. You can also utilize the vehicles many more hours since they are quiet and have zero tailpipe emissions, meaning that you can drive them in inner city scenarios even during the nighttime. And even more so when you have automated vehicles, where you can drive them many more hours per day, since you don't have to take into account drive time regulations and so forth. So how do we do this? At Einride, we have a product offering consisting of several different products. First of all, we have the Freight Mobility Platform. It's our digital service that we offer to our customers. This is an enterprise-ready platform which integrates to customer systems to ingest order data. That is what transport demand is there in the market right now. It's also interconnected with the vehicles that we use and also other infrastructure providers such as charge station providers, weather services, traffic information services, and so forth. The vehicles can be of two different kinds. First of all, we have the electric trucks, which are driven by a human being. So these are conventional trucks, but they are electrified. Fully battery electric vehicles, well connected into the Freight Mobility Platform to provide the data points that's needed for efficient operation of the vehicles. And finally, we also have the automated vehicles, or the AETs as we call them. These are the pods which are designed from the ground up to be level 4 compliant autonomous vehicles, where there's no space for a driver on board, it's only cargo. So these are designed from the start to be autonomous and also electric. These are the components of our total product offering. And this is what we provide to our customers in order to move their goods in an efficient way. And we have been doing this for quite some time. We started our first autonomous vehicle operations at a customer for almost 2 years ago. Together with DB Schenker in Jönköping, Sweden, we started moving goods for them between two warehouses. And how it looks, you can see on this movie. Wasn't that amazing? It's always chilling to see 1 hour vehicles or even 2 hour vehicles in operations at customers, making them happy and making a change and bringing the future now. To take you through the rest of the presentation, we will use a concept called worldly mapping, where we're working with the different parts of our product, and we grade them in terms of the value chain and whether there's an innovation going on or whether we can see it as a commodity. And to kick things off, I'll hand over to Pia.
We'll start right here at the base of the map with something that is not visible at all to our customers. That could be considered a commodity, but we regard it as something special enough to be custom built for our needs? Our team. We have a lot of awesome people on board, each with their own expertise. We have people with extensive knowledge in sustainability, automotive engineering, batteries, vehicle route optimization, control theory, software design, logistics, and so forth. But that's not enough. None of these skills are unique to us. It's our ability to combine them and form cross-functional, autonomous teams to make the most use of them that's unique. So we have teams with knowledge in automotive engineering, control theory, and software design to create parts of our incredible pods. We have teams with knowledge in battery optimization, route optimization, and software design to make systems that enable cost-efficient transport with manually driven electric trucks. That's hard. We have teams with knowledge in sustainability analysis, vehicle integration, and data engineering to transform execution data from our customers into information on how to make our service more sustainable and cost-effective. So, forming these teams is our secret sauce. But that's still not enough. Right, Pär?
Sir Isaac Newton once said, "If I have seen further, it is by standing on the shoulders of giants." And this is exactly what we do at Einride. We recognize that we're part of an ecosystem and we need to leverage the power of partnerships in order to be able to bring the future now. We're part of a number of different consortia and groups, some of which you can see outlined on this slide. There are, of course, many more, but these were some of the more important ones. We are a community and we're helping each other to create the change and to make the transformation as efficient and as smooth as possible.
So we covered our awesome team and the shoulders of giants. Let's move to the far right in the map. Here we find things which are available as products on the market, things we should not waste time on by building ourselves. This is where we find our software platform. Don't misunderstand me. The software platform and software in general is crucial to us. So we pick the platform's components very carefully. But picking is the important word here, because we don't want to build these things ourselves. We don't write programming languages. We don't host servers. We barely design our own APIs. What you see in this slide is a draft version of our internal tech radar. You may have seen a similar image from ThoughtWorks at some time. So the idea is stolen, but this is our guide to our own engineers when choosing technologies. So we use Go as our main programming language because it's a simple language that can be used everywhere, from vehicle to cloud. You might notice the little Java icon there as well. So it can't be used really everywhere, but in most places. We also make use of the components of the Google Cloud Platform as much as we can. For example, we use Cloud Run for most of our microservices. It's a service that you basically give a Docker image and some config, and it will run your service with zero downtime and auto-scaling. No Kubernetes knowledge needed. So that's things that we don't build, that we just pick. Let's move on to something more exciting. So now that we covered the things that we don't want to do, let's move on to the left. This is where we find things that are innovative and unique to us. And one of those things is transport planning, the heart of our freight mobility platform. Transport planning is how we take a supply of electric trucks together with a demand of goods to be moved from one place to another and combine them into a schedule for each truck, telling it or its driver where to drive and what to load and what to unload on a particular day. This is something that every company that does some kind of logistics has to do. So nothing unique here. The thing is that many companies still do this planning manually, and we just can't afford that because electric trucks are very expensive, about 3 times as expensive as a conventional diesel. And the pod, of course, is even more expensive. And charging manually driven vehicles is very expensive because the drivers on full salary have to wait while the vehicle is charged for hours. So we need an optimized plan. And with real complexity of transport networks, a human brain just can't optimize that kind of problem. So how do we do it? Well, by standing on the shoulders of giants and having some in-house expertise, of course. So this is the problem that we have to solve. We start with a set of vehicles, a transport network consisting of a number of sites connected by roads, and a set of packets or deliveries that we have to do with source and destination. And that's it. This is called the vehicle routing problem. It's a well-known problem, and if you know anything about combinatorial optimization, you would recognize this as a generalized version of the traveling salesman problem. And if you're into that kind of business, you of course know that the traveling salesman problem, and so the vehicle routing problem also, is NP hard, meaning that there is no way we can solve this optimally always. So we have to use some kind of heuristic. And the heuristic algorithm that we use is called the ruin and recreate algorithm. And it works like this. You start with some initial solution. It doesn't have to be good. It just has to solve the problem. By the way, how do we know if a solution is good? Well, we have some kind of cost function, that is some way to calculate, for example, how long stretches you drive. That's a cost factor, how much drivers have to wait, and so forth. And by combining the cost function for one solution and the result from another solution, you can know which one of these is better. So we have an initial solution. It's probably no good. We want to make it better. How do we do that? Well, of course, we do that by destroying it. This is called the ruin phase. So we randomly or semi-randomly select some of the jobs, i.e. deliveries, and we decide that these are no longer part of the solution. We don't have to deliver these packets. In real life, you'd probably have some smart way of semi-randomly selecting these, but I just choose the ones that were suitable for my example. So we removed A to F and B to A in this example. And that means we can drive shorter paths with oral vehicles, but also that we don't deliver these packets. So this is obviously not a good solution. So the next step is to recreate the solution by reinserting these jobs in some random order. So let's see what happens if we randomly select the A to F delivery to be reinserted next. Bam! We choose to reinsert it in the way that seems like it increases the cost the least. In this case, it seems like putting it on the way from B to E is a good way. And then we select the next job to be inserted, the B to A job. And we're lucky here because the green vehicle is already going from B to A on its tour. So we just load it onto that track and don't change any paths. So now you've recreated a solution. The question is it a better solution than the first one? Well, probably yes, because there's a lot less trucks driving around, a lot less colored lines here. So my intuition would say that this is a better solution, but I haven't checked the const function, so I don't know. But let's say this is a better solution. That means that we go back to the room phase, we remove some jobs, some other random jobs, and recreate again. And we do that iteratively until we have a good enough solution, or until we've done enough iterations, or until some time limits kicks in. And then we just take the solution we have then and say that this is the best solution we have. So now you know how we solved the vehicle routing problem. Why did I give that secret away? Well, because that's just the shoulders we stand on. We use an open source solver to solve the vehicle routing problem for us. It's called JSprit and it's written in Java and very extensible, very fast. So that's something we don't do because it's already done for us. There are also commercial solvers out there. But our problem is that we have a much trickier problem to solve, the electric vehicle routing problem. So what is so hard about the electric vehicle routing problem? Well, electric vehicles today can only reach a certain distance before they run out of battery. So if we don't model charging, we can't reach sites that are far away from the hub. For example, we might not be able to reach F in this picture, so we have to skip any deliveries to or from that place. Not exactly the cost-efficient transport that we want to offer. So we have to model charging. What's so hard about that? Well, first of all, it doesn't fit into the standard model. It's something that takes time, but it's not a delivery job, and we don't want to do it unless it's necessary to reach a delivery site. And then, when we find a suitable way to model chargers on the sites and along the road, how do we charge in an efficient way? We get to choose from a lot of alternatives about where and how much to charge. A lot of alternatives is not a good thing in combinatorial optimization. Evaluating a lot of alternatives, it's basically what kills us. It is what makes solving NP-hard problems infeasible for real-world problems. As if that wasn't enough, chargers are a shared resource in the network. That means we need to coordinate the tours of the vehicles so that they don't charge at the same charger at the same time. So we need to optimize across the vehicles. So while solutions to the vehicle routing problem are well known and available as products, solving the electric vehicle routing problem is in a good enough way. It's still research that we're doing in order to solve our business problem. I don't have time to tell you all the details of how we do it, but trust me, it's not easy, but the results are looking good.
And for the last part of the presentation, we're going to look at the pod, or the autonomous electric vehicle, the AET that we build. This is a very visible part of our offering, which is highly innovative. This is where we really stretch what we can deliver in terms of a company and in terms of technology maturity. So let's look a little bit on how it looks when we're developing stuff for the pod. On this slide here, you can see a clip from our simulator. And what you can see is actually in the bottom part here, we're simulating a chicane, the last part of the Goodwood track in the UK. A chicane is a part of a racetrack where you have two curves following right after each other. And one important aspect in order to proceed through a chicane as fast as possible is to be able to hit the apex in both of those curves. This is something that's quite complex to do, something that race car drivers spend an entire lifetime practicing in order to reach. What we program our pod to do here is that we program the road boundaries, that is the edges of the road on each side. And then we set a parameter for the optimizer where the intent of the optimizer was to increase the speed as much as possible while staying within a boundary for lateral or sideways acceleration. Because if you exceed the sideways acceleration over a specific limit, one or two things happen. If the traction is poor, you will spin out and you will spin out of control and most likely crash the barrier on the side of the track. Or if you have enough traction, the vehicle will actually tip over and tilt on its side. None of which we would like to happen, of course, but still we wanted the vehicle to traverse the chicane as quickly as possible. So we put the vehicle through through its motions. First we were driving really slow and the vehicle optimizer stayed in the center of the lane. But one interesting thing happened when we increased the speed. And that is that the vehicle was approaching more and more the race line. That is, it was hitting the apexes in both of the curves. And listen closely to the commentary when we're driving this in real life, what the people say. They are professional race drivers and they comment on the race line or how the vehicle is actually progressing through these curves. And remember, this was an optimizer solving a problem, a mathematical problem to minimize the lateral acceleration while still making the speed as fast as possible. So let's look on how it looks in real life.
The chicane's going to be a test, isn't it?
It really is. I mean, that is. Have we got any stats as to how wide it is? Because it doesn't look much narrower than the gap between the two walls.
This is it really is intriguing now to see, but the chicane has not been moved.
By the way, that's reasonably quick.
It is, isn't it?
Well, it made mincemeat of it.
Well, that's an impressive line, an impressive lap. Very good indeed. So the Einride autonomous all-electric truck completes its lap.
Again, wasn't that amazing? To wrap up this presentation, it has in many cases been about bringing the future now, taking on large ambitions with very few resources. And a common theme with the technology that we are building at Einride is optimization. So it can't be stressed enough that optimization is something that goes into all aspects of what we're building and what we're doing. And we not only have to work with optimization as a technology area, but we also have to optimize the way on how we work with it. We work with it with a super efficient organization. We work by carefully selecting what we do and what we actually let others do, or what we get from our partners and colleagues from other companies. You also have to be very developer friendly to be efficient, because when you have happy people, you will get an amazing team and you will get amazing results from that. And that is something that we learned at Einride, making sure that everyone working at Einride is happy and confident and have the right tools to deliver awesomeness in every day that they do it. That's really one of the key success factors behind what we're doing. And we also mentioned standing on the shoulders of giants. We're part of an ecosystem. We're working together with everyone within the community. One example which I would highly recommend is to go over to our GitHub page and check out all of the cool libraries that we have made open source for the community to check out, to contribute to, or to benefit from. So with that said, I would like to thank you for listening. Myself and Pia, we are really happy to be part of this conference. And to all of you out there, stay safe and take care. Bye for now.